Hi, my name is Guang, 12 years old. For this lesson, we'll be continuing with techniques of definite integration. For this lesson of techniques of definite integration, we'll be doing with double integration. X squared plus y squared is smaller or equals to 1. So over here, it's basically saying that so this is the shape. So the radius over here is smaller or equals to 1, basically from 1 to 0 or 0 to 1 if you want to. So from 0 to 1. So for this part, what we're going to have here is that, so this is our range. So over here, what we're going to have is that we're going to have two parts which is separated by this line. So there is the part, so these two are the parts. So for these two parts, you may be wondering what's the difference. So for this part, it's basically the positive part for both x and y, and the second part is basically the negative part, okay? So, and in order to do integration, you cannot have modulus inside. So if you use bracket for I, because that it is the positive part, so for this part you don't have to change it. So it just become y plus 3 square root 3, square root 3x dx dy. On the other hand, for this part, no matter how you look at it, if it's for the second part over here, it's negative. No matter no matter how you look at it, it's going to be negative. So for this part, in order to keep it as positive, so you here need to minus this. Okay? Alright. Now that we have gotten this two parts, we can, so because this is a circle, so we are going to change this from Cartesian coordinates to polar coordinates. So for this part over here, it's going to be, so the Cartesian coordinates over here, the polar coordinates, what is y equals to and what is x equals to. So why don't we just so y is going to be equals to r sine theta, while x is equals to r cosine theta from this part, okay? So we have known what x and y are, right? But so here what we're going to have is that r sine theta plus square root 3 r cosine theta. And remember, so for this part over here, if you're going to change from Cartesian to coordinates, you need another r, because that for this part we have, so this part is dr, right? And we will have a d theta over here, but over here for this part, dl is r d theta. So over here, to change it to polar coordinates, we'll be having r d theta. But wait, what about its boundaries? We cannot solve it without its boundaries, because this is clearly definite integration, because we had them over here. Well, for this part, the x squared plus y squared is smaller or equals to 1. So it's until here, this part is going to be 1. So the range is basically for r. The range is from 0 to 1. But what about for d theta? Well, for theta, what is the range? We're going to look at part 1 first. Okay, because at part 2, I'm going to continue on later. So part 1 over here, for this part, we will tell over here that this is, so when we solve these kinds of, when we need to solve this kind of integration, going to use radian instead of degree, okay? So over here we're going to use radian, but over here for this part you can tell that this is 0 and this is pi, okay? So for this part over here, it will be the angle here. The angle here is pi over 3, and the angle here is also pi over 3. So what's the range? Well, it starts from this part and ends over here. So for this, we'll have from negative pi over 3 to, until this, so this will be pi, right? So that means that this pi is until 2 pi over 3. So the range here is from negative pi over 3 to 2 pi over 3. And now moving on to the next one. For r is still the same. Oh wait, what is the range now? The range, instead of going from here to here, you'll be going from here to here. Well, over here for this part, what we're going to have is that we're starting from 2 pi over 3, as you can see. And this part over here, 2 pi over 3 pi, then what over here it is 5 pi over 3. And here we have the boundary for both r and theta. Now that we have gotten it, what we're going to continue on is, so we can take out the r, and we can separate it to whole iterated integration, whereas we'll have so what we're going to have is sine theta plus square root, square root 3, and then we have cosine theta integral, and here we have the d theta. Then we have the integral from 0 to 1 r squared dr, and it's same case over here. From 2 pi over 3 to 5 pi over 3. From then after that we have sine theta plus square root 3 cosine theta sine d theta sine from 0 to 1 r squared dr. So the integral for this part over here, what we're going to have is that we can integrate already. So over here for this part, I'm going to leave it here for a sec. Later I'll integrate it. And then here we'll have r cubed from 0 to 1, and then here we'll get, and we'll minus 2 pi over 3 to 5 pi over 3 sine theta plus square root 3 cosine theta d theta. Then after that we have 2 times the same thing again. And now that we have gotten this, so what we can do is to start in, so here will become 1 over 3 minus 0. So here we'll have 1 over 3, and we can, and now that we have gotten what this is, we can also integrate for this part. So if we integrate for this part, what we're going to get is, so sine is going to become negative cosine theta, cosine becomes sine, and then it will be from negative pi over 3 to 2 pi over 3. And then after that we'll also have will minus 1/3 because of this part, and will times for this minus cosine theta then after that plus square root 3 sine theta from 2 pi over 3 to 5 pi over 3. Okay, now that we have gotten this, what we're going to have next is that we are going to sub in the boundaries. So we're going to do it one by one. So as you can see here for this part, cosine theta, so cosine theta as if 2 pi over 3 sub in, it will become negative. So cosine pi over 3, it is equal to half. While 2 pi over 3, well, 2 pi over 3 is on the second quadrant, so for this part it will become negative, and 2 negative become positive. So it becomes half, then you are supposedly going to minus this part, but there's another negative, so it's a plus, but over here but we have to still look at this. So cosine negative pi over 3. So which quadrant is that? And so yeah, so in this quadrant it will still be positive, and you get another half. Wait, then what is sine pi over 3? Sine pi over 3 is equal to square root 3 over 3. I mean 3 over 2. So what we're going to have here is that, so sine 2 pi over 3, what is it going to be? So sine 2 pi over 3 would be here positive for this as the second quadrant, while for this part over here you have square root 3 over 3 times square root 3 times square root 3 over 2. Then you over here minus, so over here for this part you have square root 3 times, so sine negative pi over 3. So sine negative pi over 3 is going to be a negative, so here we have a positive, then square root 3 over 2. Then minus 1 over 3. Well, you can put this plus if you want to, but in case of confusion, I'm just going to put some minus for now. Okay, so for this part, what we're going to have here is that, so when you sub in 5 over 3, what you're going to get is a negative half, okay, because of this minus. Then you minus becomes positive, but once again 2 pi over 3, so it's going to be another minus half, and then what we're going to have here is that square root 3 sine theta. So over here what we're going to have is that, so sine 5 pi over 3, it is negative. Well, later I'll tell you why this part I wanted to change this to positive just now. So for this part, when you sub it in, it will become square root 3 times square root 3 over 2. Then it will minus, so sine 2 pi over 3, it will become square root 3 over 2 without the negative, so it becomes square root 3 times square root 3 over 2. And why I wanted to change this to positive? Well, if I change this to positive, what we're going to have is all of them will add together. So now that we have gotten this part, what we're going to have next is that, so we basically just times the square root 3 and square root 3 together. Okay, and now that we have gotten this part, what we're going to have is that, so these 4 plus together and these 4 plus together is basically 4. So these 4 plus together is 4, and then 4 over 3 plus 4 over 3 is equals to 8 over 3, and that's the result that we get over here. Okay, so for this lesson what we mainly did was we separated into 2 parts. One that we can tell is definitely be positive, and other being the negative, and the other one will be below 0. So here we use minus to keep it positive and all. Then for this part, we change from double integration to iterator. Then after that, we do our integration. And that will be all for this lesson. Last but not least,